Hi everyone, this is Sunny Kumar from IIT and welcome to my channel Code with Sunny. And today I am going to discuss the problem, the maximum set of Hackadearth March Easy 2021. So let's jump directly into the problem statement. We have been given an array A of size n containing n integer elements and a pair of elements I, j is said to be an inversion if ai is greater than aj and I is less than j for every value of ij belongs to 1 to n. So here basically we have been given the definition of an inversion. Now what we have to do here is using this array we can create an undirected graph G of n vertices for each pair, that is inversion pair I comma j. You can see here there exists an edge between vertex I and vertex j. Okay, now we have to find the maximum size of set S consisting of vertices from graph G such that there exists an edge between every pair of vertices that is present in S. Okay, so basically we have to find the maximum size of set S such that such that the elements of this set are sorted in decreasing order, and we have to find the maximum size of the set. So if you are not going to understand this statement, no need to worry about, because I am going to explain you with the help of the example. So let's first discuss the input format. We have been given the integer t as the test cases and the integer n, the size of the array, then the elements of the array. Okay, so we have to print the maximum size of the set as in the new line. So number n is going to vary up to 10 power 5 and the array values up to 10 power 6. Okay, so O of n square solution will fail here because we can't have the number of iterations exceeding 10 power 8. So let's discuss the problem and analyze how we are going to do this problem in most efficient way. Okay, so let's move further. So what is given actually in this question? We have been given an array of n elements and graph G is built for every inversion pair. Okay, and inversion pair is basically a of I. This is, let me write down here, inversion pair is basically a of I greater than a of j and I less than j. There is an edge between I and j. Okay, and we have to find the maximum size of the set S, which consists of vertices from the graph G, and if we try to find out the every pair of vertices, then there must exist an edge between these pair of vertices. So we have to find the maximum size of set S such that every pair is an inversion pair. So how we are going to do this? So let's move further to analyze this. So our prerequisite to solve this problem would be basics of dynamic programming and longest increasing subsequence concept. So how we are going to apply these two concepts in this problem? So let's understand this with the help of the example. Okay, suppose we have been given the array like this according to the definition. So according to the definition, let me write, according to definition, all the edges, let me write, all the edges are built which satisfy the inversion criteria. Okay, so which edges, that is, let I am going to list down all the indices which are going to satisfy the inversion criteria, that is a of I must be greater than a of j and I should be less than j. So what are the indices I comma j that is going to satisfy these criteria for the given actual array? So it will be like a of I should be greater than a of j. So if we consider the one based indexing, then pairs will be like 2 comma 3, and let me list down fast, 2 comma 4, and again you can see 2 comma 5, 2 comma 3, 2 comma 4 and 2 comma 5, obviously because 5 is greater than 1. And again if you can list out all the possible pairs, it will come out to be 3 comma 5, and you can see the last pair would be what, 4 comma 5. Okay, so these are the indices. You can see the indices 2 comma 3, the element is 5, and the at index equal to 3 the element is 2. So inversion criteria is satisfied. And again 2 comma 4, again 2 comma 5, again 3 comma 5, again 4 comma 5. These are the inversion pairs. Also I have left some pairs that are actually inversion indices 1 comma 3 and indices 1 comma again 4 and indices 1 comma 5. So if these are the valid pairs, but if you count the total number of pairs, you can find that it is not equal to, let me write, not equal to n into n plus 1 upon 2. That is, total number of pairs must be n into n plus 1 upon 2. That is, you can, no, sorry, I've written something wrong, n into n minus 1 upon 2. Okay, so total number of pairs must come up to be 10, but if you see that, then the total number of pairs here in the actual array is not equal to 10. 1, 2, 3, 4, 5, 6, 7, 8. Total number of pairs is coming out to be 8. We are still missing two pairs. So this is not the valid set. Valid set S. So what is the valid set S? So what is the valid set S? Let's first understand this. So valid set S would be the set S consisting of all the vertices which satisfy the inversion pairs. Consisting of all vertices satisfying inversion criteria. Okay. So it will be the set of all the vertices satisfying inversion criteria. So if we select the array elements like 4, 3, 2, 1, you can see the total number of pairs would be what? N into n minus 1 upon 2, that would come out to be 6. And if we calculate the total number of inversion pairs, let me write total number of inversion pairs, it will come out to be again 1 comma 2 and again 1 comma 3 and okay, again you can see it will come out to be 1 comma 4 and again you can see 2 comma 3 and again it will come out to be 2 comma 4 and again it will come out to be last one, it would be 3 comma 4. So if you look at this, these are the valid pairs of indices satisfying inversion criteria and it will come out to be 6. That is, the total number of pairs, distinct pairs, is exactly equal to the total number of inversion. This is the valid set. So which type of array will give us the valid set S? Note that whenever we have the elements sorted in decreasing order, all the pairs, that is count of all the distinct number of pairs, will be exactly equal to the total number of inversion count of the array. So we need to focus on how to find the subsequence from the given array satisfying that all the chosen elements are in decreasing order. So but we have to find the maximum size of the set S. So overall, let me write, so I am going to write overall, find the maximum, or you can say find the longest decreasing subsequence of the given array. So if we find the longest decreasing subsequence of the given array, we will have the array like A0, or you can say we will have the array like with indices, let's say chosen indices will be k1, k2, k3 up to, let's say, km, which are the chosen indices, and these indices are of the longest decreasing subsequence. Okay, so we have to choose the longest decreasing subsequence. So our problem simplifies to find out the longest decreasing subsequence of the given array, because the total number of inversion count of such array, that is such elements chosen form an array. Such array have the inversion count exactly equal to the total number of distinct pairs of the given array, or you can say of the new array that I have found. Okay, so how to calculate this uh, longest decreasing subsequence? So our problem simplifies to how to calculate longest decreasing subsequence. So the main idea is to use the dynamic programming. Let me write, use dynamic programming you can define a DP state where the where index I, where you can say DP of I will define the maximum, or you can say longest decreasing subsequence sequence up to index I. But you can see if we try to approach using this DP state, it will obviously come out to be O of n square solution, because for every I we are going to find we are going to traverse from the backside of the array, and for every I we will traverse a j exactly equal to the end of the array up to the current index I. So it will give us a O of n square solution, which will not pass because you can see the constraints here, n is varying up to 10 power 5. So we need an efficient solution. So I am going to write this will give TLE. So what is the efficient solution? So it will be, what is the efficient solution I am going to use to find out the longest decreasing subsequence. Note that n log n solution, let me write n log n, n log n solution will obviously pass. Oh, let me write OVUSLY pass. So what is the n log n solution? It is basically nothing but binary search. So if we perform the binary search to find, let me write to perform binary search to find longest decreasing subsequence. So how we are going to perform the binary search to find the longest decreasing subsequence? So it is basically reverse the array. So I'm going to write here in a cleaner way, reverse the array and find the longest increasing subsequence. So if we find the longest increasing subsequence after reversing the array, it will be equivalent to finding the longest decreasing subsequence. So how to find the longest increasing subsequence? In log of n log n time, we have to find the longest increasing subsequence. So how we are going to find this? So I am going to find it out using the help of lower bound, let's say lower bound function of HTL. So if you are using Python, then no need to worry about, just implement the lower bound function. You can do it by your own using the help of binary search. This is predefined in HTL, C++ HTL. So how I am going to do this? Let me demonstrate with the help of example. So I am going to pick up this array 45231. Okay. So let me write. I'm going to print this. So if I'm going to reverse this array, what would be our new array? It would be like 1 3 2 5 4. Okay. So let me maintain a stored vector. Note that our minimum length of longest increasing subsequence will be always 1, that is choose any element. So first I'm going to, if I'm going to reverse my vector, it will become 1 3 2 5 4. So I'm going to initialize my store of 0, that is I'm going to push back a single element to my store vector. It will be like store of 0 equal to 1. Now what I'm going to do, I'm going to iterate from 1 to vector dot size, let's say array dot size -1, that is now our next step would be what, push back 3. So what I'm going to do, I'm going to find the lower bound, of 3, that is array of 1 if I'm considering the 0 based indexing in store vector. So what is the lower bound of 3 in a store vector? You can see store vector contains a single element 1. If I need to find the lower bound of 3, you can easily see that the iterator will point to the store dot end, that is end of the store vector. So if whenever we our iterator point to the end of the vector, it means we have found an element that would contribute towards the longest increasing subsequence. So our main idea will be, whenever we find a we find our iterator after taking the lower bound pointing towards the end of the store vector, we need to increase our store vector size. That's why I am going to push the element into store vector. Okay, so our new store vector would be like 1, and 3 will be pushed, it will come out to be 3. And again our next sequence of operation will be 2. So I am going to find the lower bound of 2, find the lower bound of 2 in store vector. So what will be the lower bound of 2 in store vector? You can see, if you take the lower bound of 2 in store vector, if previously it was 1 3, so our iterator would point to the index equal to index of the element 3. So if whenever we haven't encountered the iterator pointing towards the store vector's end, then I am going to update the iterator position with my new element. So if I am going to do that, our new store vector would be like 1 2, because 3 element 3 is going to be updated by 2. And again, if I'm going to do that, the sequence of operations like this, then I will find that our next element is 5. So I'm going to find the lower bound, and if now you can see the lower bound of 5 in my store vector currently will point towards the end of the vector. So I'm going to update my store vector, it would come out to be 1 2 5. And again you can see our new element is 4. So I'm going to find out to the lower bound of this in my store vector, it would come out to be 1 2 4, because I'm going to update that element. So finally stored vector size will be the longest increasing subsequence. Okay, so this will be our main approach. Using the help of the lower bound, I am going to update my store vector to find the what are the elements contributing towards the length of the longest increasing subsequence. So let's move on to the approach. So we need to find the longest decreasing subsequence, reverse the array to find the longest increasing subsequence. So one thing I need to mention here for the clarification, that is for inversion count exactly equal to total number of pairs possible for the given array. Let me write, array must be sorted in decreasing order. Okay, so for array to be sorted in decreasing order, we need to find the longest decreasing subsequence to maximize the size of the set S. So how to find the longest decreasing subsequence? For simplicity of the calculation, we are going to reverse the array and find the longest increasing subsequence. Maintain a store vector to store the longest increasing subsequence, and initialize our array with array of 0. Now iterate in the array from 1 to n minus 1 and check the lower bound of the current element in the store vector. If the iterator points to the end of the store vector, we are going to push the element in the store vector to at the end, that is increase the store vector size. Otherwise, I am going to update the element in the store vector at the current iterator position, since we found the smaller element. That's why I am going to update. Note that our length of the longest increasing subsequence will be the size of the store vector finally. This approach will give us the time complexity of O of n log n and space complexity of O of n. N log n is because each time we are going to iterate in the array n times. So, and the binary search lower bound is giving the time of log of n for every element, that is for every index I. So time complexity goes to O of n log n, and the space complexity would be O of n, because in worst case our store vector will have the size equal to O of n. Okay, so let's move on to the implementation of the code. Okay, now let me expand this first. Okay, now you can see here I have the code. Now where t is the number of test cases, n is going to denote the size of the array, and I have taken the inputs of the array, and let's reverse the array to find the longest increasing subsequence. Now our minimum answer is will always be 1, that is to choose any element. Now I have a store vector defined here, and by default I am going to push the very first element after reversing the array, that is store.pb pushback v is of 0. Now I am going to iterate in my array from 1 to the end of the array, and take the lower bound of the current element of the array in my store vector, and if it is going to point to the end, as you can see here, I'm going to push that element into my store vector, thereby increasing the size of the vector, because this element is contributing to the length of the longest increasing subsequence. So we need to update that, that is increase the length of the longest increasing subsequence by 1. Otherwise I'm going to update the element, that update the vector, because we have find the smaller element, so I need to update the element first. Okay, so note that our longest increasing subsequence, which would be our answer, which is the equivalent to longest decreasing subsequence, because since I have reversed the array, so our answer will be directly the store dot size, that is size of the store vector. Okay, so let me submit this code and check it out if it is going to work fine or not. Yes, it is working fine. So, if you have any doubts, do not forget to mention in the comment section of the video. And I will ask the viewers to like this video, share this video, or do subscribe to my YouTube channel for latest updates. Thank you for watching this video.